All right, let's get right into it. Today, we're basically crashing a university lecture to get to the bottom of some of the biggest buzzwords out there: AI, machine learning, and deep learning. We're going to take what a professor teaches her class and boil it all down into one simple explainer. So grab a seat. Class is officially in session.
So the professor, Dr. Law, she kicks things off with this exact question. She asks every single one of her classes this because, it gets right to the heart of all the confusion. People use these terms like they're the same thing all the time, but they're absolutely not. So let's figure out the answer. But to really get that answer, we've got to zoom out first. We need to look at the big picture, what I like to call the AI family tree. It's all about seeing how these ideas fit together, starting from the very beginning. So way back in the day, what we called AI was really just a super complicated instruction manual. You can think of it as a bunch of if-then rules. Humans, actual people, would sit there and write thousands of lines of code like, if this happens, then do that. The machine was smart, sure, but only because we told it exactly what to do. It couldn't learn a thing on its own. And this is where the entire game changes. Modern AI, which is mostly what we call machine learning, isn't about following rules we wrote. It's about learning the rules for itself. We just throw a ton of data at the machine, and it starts to see patterns and make its own decisions. It learns from experience without us having to handhold it every step of the way. So here's the most important thing to get straight in your head. It's a hierarchy. Artificial intelligence is the big, giant umbrella term for any smart machine. Machine learning is just one way to do AI. And deep learning, that's an even more specific, crazy powerful type of machine learning. They're not different things fighting each other. They're nested inside one another like Russian dolls. Okay, so that idea brings us right back to Dr. Law's original question. If deep learning is just a type of machine learning, what actually makes it deep? Well, it turns out the answer is actually really, really simple. It all comes down to one little number. Here it is. This is the core difference. Both of these methods use something called neural networks, which are kind of inspired by how our brains work, processing information in layers. Now, standard machine learning, let's call it shallow learning, it only uses one or two of these processing layers. And it's great for simpler stuff, like predicting a house price from a few data points. But deep learning, well, it's built for heavy-duty complexity because it uses a lot more layers. And this is it. This is the magic number. The moment a neural network has 3 or more of these hidden layers, we officially call it deep learning. That's the cutoff. That's the whole secret. And having more layers is what lets it understand really complex stuff, like what's in a picture or the nuance in a human voice. Dr. Law has this fantastic analogy for it. She says regular machine learning is like a house with 1 or 2 floors. It's perfectly fine. It gets the job done for everyday life. But deep learning, that's like a skyscraper. It has tons and tons of floors. You need that massive, complex structure to handle much bigger, more complicated tasks. Okay, so we've got the theory down, right? Now let's get into the practical side of things. In a little chat before class, Dr. Law drops some really fascinating and honestly kind of counterintuitive secrets about how data scientists really build these things. I mean, this is a bit of a shocker, right? An AI professor is saying she doesn't want her models to be perfect. She literally tells her students if they get a score in the high 90s, they've probably done something wrong. And that leads to a really interesting question. I mean, seriously, why would you ever aim for a lower grade? It goes against everything we think about science and getting things right. But there's a really, really good reason for it. The reason is a huge problem called overfitting. See, a model that's nearly perfect has pretty much just memorized the answers to the test. It's like a student who knows the answer key for one specific exam, but has no idea how to solve a new problem. So by aiming for something like 80 or 85%, you're actually building a smarter model, one that can generalize what it knows and handle the messy, unpredictable real world. So building a great model isn't about being perfect. It's about being flexible. And a massive part of that comes down to the data you give it in the first place. Dr. Law says one of the most important and most overlooked parts of the whole process is something called feature engineering. And she has another great way of explaining this. Think about building an AI model like you're cooking a meal. All the little bits of data you have, those are your ingredients. Now, you could have 50 different ingredients on the counter, but a great chef knows that the secret is picking just the 5 or 6 that really matter. Feature engineering is just that.
It's the art of choosing the most powerful ingredients to get the best tasting dish. So we've covered the theory, we've touched on the art of building these things, but why does any of this matter to you? Well, because these multi-layered skyscraper models are already running all sorts of things you use every single day.
You know when you unlock your phone with your face? Yep, that's deep learning. It has to process thousands of little points on your face in a split second. A simple, shallow model could never handle that. Or how about when you use an app like Gemini to translate something on the fly? You're using a deep learning model. It's not just translating words, it's understanding grammar, context, and slang. That's the kind of complex stuff that needs that deep skyscraper architecture.
And of course, the big one, self-driving cars. They rely completely on deep learning. They are constantly taking in this flood of video data, identifying people, other cars, stop signs. That is a job way, way too big for a two-story house model. So let's end this right back where we started, with Dr. Law's main point. This single sentence really just sums it all up perfectly. Both regular machine learning and deep learning use neural networks, but it only gets to be called deep learning when that network has 3 or more hidden layers. Simple as that. And that leaves us with one last big thought to chew on. The huge shift from the old AI to the new AI is that these machines aren't just following our orders anymore. They're learning from our data, our choices, our behavior, which kind of makes you stop and wonder, what exactly are we teaching them?